that is electric charges and the fields. Okay, so electric charges and the fields, this is another one important. Every year we'll be getting a question from this particular concept. So based upon the previous analysis and all the questions analyzing them, these are the very important topics that will be asking in the examination, that is Coulomb's law, electric field, and field due to the different charge bodies. Okay, so field due to the different charge bodies, you should be very careful. You should remember all the formulas, please. You should remember all the formulas of the field in this particular situation. Okay, so now coming to the concepts. So what is this Coulomb's, or it can also be called as in Coulomb's inverse square law? So as we know, there will be the two types of the charges. So what are they actually? So there will be the positive charge and there will be a negative charge. If a body is abundant of the negative charges or number of electrons are more, that body can be called as a negatively charged body. And if a body is of less number of the electrons, then it is a positively charged body. By the way, the basic charge value of the positive or the negative is going to be 1.6 into 10 to the power of minus 19. This particular thing we know. Okay. And another one is the charge can be quantized, that is, charge q can be written as n plus or minus n into e, where n represents for an integer things, please here, that is 1 comma 2 comma 3 so on. The charge can be quantized and the law of conservation of charge is also being validated, please. So now, when two charges are there, whether they will be like charges or unlike charges, that means if two charges are both of them are the positive or both of them are negative, that means like charges. Or if one charge is positive and another charge is a negative one, then there exists a force between them. So between the like charges, there will be an repulsion and here attraction. Whether it is an attraction or repulsion, it is nothing but a force. And the value of that particular force is given by the coulombs. And according to the Coulomb's inverse square law, that force of attraction or repulsion will be directly proportional to the product of their charges q1 into q2. And that force is inversely proportional to the square of the distance between the both the charges. For example, you are having a charges over here. This is a positive test charges q1, and here there is another positive test charge which is q2. Both are separated by distance r. Then the force between them can be written as an 1 by 4 pi epsilon naught into this is q1 q2 by r square. So this is the value of the force, and this force is called as a Coulombic force. So this in this one, the value of 1 by 4 pi epsilon naught can be written as it is 9 into 10 to the power of 9. And you can write the epsilon naught value as epsilon naught is equal to 8.85 into 10 to the power of minus 12 Coulomb square by Newton into meter square. So what is this epsilon naught? Epsilon naught is the permittivity of the free space. Okay, so epsilon naught is called as a permittivity of the free space. That means it is the in which it is a space or a medium in which the electric lines of force can move freely. For example, there is a positive charge here and there is a negative charge here. The lines which will be coming from the positive charge, they will be terminating at the negative charge. So the starting point will be the positive and termination point will be the negative charge. So the medium in which they are going to be passing, if that is of a free space, then you can then you can write it as an epsilon naught is the value of that. Instead of the free space, if any other medium is there, any other medium, then instead of epsilon naught, you will be writing it as an epsilon. Okay. And the value of that medium can be obtained by epsilon is equal to relative permittivity into epsilon naught, where relative permittivity can also be written as a can called as a dielectric constant. Okay, so this is the basic function and basic formula of the force between the two charges or the Coulombic force. The vectorial representation between these two things can be written as an this is 1 by 4 pi epsilon naught. It is q1 q2 by r cube into r bar. This can be obtained by multiplying an unit vector r to this one. Fine. So now this is the force conditions. Okay, so now in between the positive charge and the other positive charge Q1 and Q2, there is a free space. You have written the formula fine. Instead of the free space in between them, between the positive charges Q1 and Q2, if some portion or the total portion is being filled with some medium, it is completely filled with the medium of permittivity epsilon, then what will be the force? Let me take this as an F dash is equal to 1 by 4 pi epsilon naught, sorry, epsilon into this will be the Q1, Q2 by R square. So since we have utilized it, since we have used this particular thing, we have changed the medium over there instead of taking a free space. So this will become as an epsilon. Okay. Or else this can be written as an 1 by 4 pi epsilon can be written as a relative permittivity into epsilon naught into this will be the q1 q2 by r square. This is the distance in the medium, whereas this is the distance in the air or the vacuum or in the free space. So fortunately or unfortunately, if these two forces are going to be the same, that is F is equal to F dash, then what will happen? The common terms that is Q1, Q2, 1 by all these things will be cancelled over there. And you'll be left with that is the r square, that is the distance in the air or the vacuum square is equal to epsilon r relative permittivity into distance in the medium. Okay, or the equivalent distance of the air, the equivalent distance of the air is equal to the root over epsilon r into distance in the medium. The same epsilon r can also be written as an root over k into distance in the medium. This is a very important relationship, please. So where we can use this particular thing. So where you can use means suppose the distance between the two charges is the same charges I'm taking here. One is Q1, another charge I'm taking it as an Q1 and this one as an Q2. If the space between them is being filled with an dielectric or an a partially filled medium of thickness T and your relative permittivity value of the K and the distance of separation is going to be the R, then the force between the two charges can be written as an F is equal to 1 by 4 pi epsilon naught into. So charges will be your Q1, Q2, same thing. But now coming to the distance. The distance in the air is R minus T plus the equivalent distance of the medium in terms of the air can be written as an root over k into thickness T whole square. So this is how the force can be calculated if the distance between the charges is partially filled with an dielectric conditions. Okay, so please remember this one. It's a very important relationship. Okay, now coming to the sums on this particular thing, what type of a sum? This is one of the model that you can be asked. So 2 point charges A and B are there here, having the charges plus Q and minus Q. Remember, there is an attractive force because the charges are opposite charges are placed at a distance d apart. So force between them is F. Now the 25% of the charge A is transferred to the B. Then what will happen to the force? So fine, as the distance is going to be the same, and we know that force is going to be directly proportional to the product of the charges. And so based upon this particular phenomenon, you can go for this one. So if 25% charge on the A, the force charge Q1 is equal to Q. And if I take the charge Q2 is another one as an something as a Q like this, then initial force can be written as a proportional to the Q1 into Q2, and that will be equal to the Q square. Now what's happening is Q1 is being 25% is being reduced. That means how much charge will be left over with the first A is going to be the 75% of the total Q. And because of this, or this can be written as an 3 by 4 times of the Q. Now Q2 has been converted as a 25% is added to the Q2. Then it will be the 125 by 100 of the Q. So this becomes as an 5 by 4 times of Q. Okay. Now what will be the case in this situation? Okay, so now the force is going to be the F by the F dash is equal to initial charges Q1 into Q2 by, let me take this as a Q1 dash and Q2 dash by Q1 dash into Q2 dash. So on this particular thing, you can substitute the values over here. That is Q1 by into Q2 by Q1 dash is 3/4 of the Q1, and whereas the Q2 is 5 by 4th of the this is your Q2. So on solving this one, you should be getting this one F by F dash is equal to that going to be the 16 by. So this is going to be the 15 conditions. So she is asking that 25% of the A is charge if the A is transferred to the B. Now the force between the charges is going to become as a. So now this can be written as an F dash is equal to 15 by or 15F by 16 times this one. Okay, so now the force is going to be changing. So if the distance is also being changing correspondingly over there in any situations like this, so you can solve that particular thing. So in this one, 25% of the charge A is being transferred. 25 that means charge A is being reduced by 25%. So if it is reduced by 25%, it will be the 75 by 100 of the Q. That means it becomes as a 3 by 4 of this one. Now charge Q, apart from its initial charge, that means Q2 dash should be equal to the initial charge Q plus an additional of Q by 4, that is 25% is been added to this one. So it will become as an 5Q by 4. So the same thing we have written. So these type of the questions can be asked in this particular scenarios. Or else you can also have the different questions can be asked here. So please be careful of this particular force conditions. The main important thing in the force you have to remember is force is proportional to the product of the charges and force is inversely proportional to the square of the distance between them. So this is the main important relationship here. Now coming to our next topic, that is an electric field here. Coming to the electric field is nothing but it is a space around a charge where its influence can be fed. That means if I place another charge around this positive charge, or if I bring another positive charge called as an Q naught close to the Q, there will be a repulsion. So this repulsion will be taking place up to a certain distance only from the Q. That entire region around this particular Q where it can repel the Q naught, that entire region is called as an electric field. So electric field is a vector quantity represented by the E bar. So it's a vector quantity, sir. So electric field can be defined as an force acting in on an unit positive charge, that is Q naught. So this can be written as an F is equal to this is 1 by 4 pi epsilon naught into this will be the Q naught by distance of separation some R square by Q naught. So if I remove that particular Q naught, it will be the 1 by 4 pi epsilon naught into Q by R square. Okay, so this is your electric field vector. So electric field for a positive charge, the field direction will be the out of the positive charge like this. This is the E bar direction. So electric field will be coming out of a positive charge, and electric field will be in if it is a negative charge, then electric field will be acting into the negative charge. So please be careful of this one. Okay, that means, for example, if you are having a positive charge and a positive charge here, then what will be the field in between them? So because of the positive charge, one of the electric field will be in this direction, E1 is in this direction, and obviously it is also positive charge, so E2 will also be in the this direction. So both the directions are opposite. So in this scenario, the net electric field in this case can be written as an E1 minus E2 or E2 minus E1, depend upon the situations. If it is a positive and there is a negative charge over there here, sorry. So if it is a positive and a negative charge here, because of the positive charge, field direction will be away from here E1, and since it's a negative charge, E2 will be in this direction. So net charge is going to become as an, this will be the E1 plus E2. So net electric field will be the sum of the two electric fields. It's an vectorial sum. You should be careful. Based upon the directions, you have to add or subtract them. Or if it is a negative charge here and there is a negative charge here, then the electric field will be acting into them, please. So this will be the E1, this will be the E2. So in this scenario also, it will be the E1 minus E2. So this is the net electric field in this situations, please. So these are your, like this, the electric field will be acting. It will be out of the, for the positive charge, and it will be the into and negative charge. So please be careful of this one. Now, this isn't for the point charges where we are discussing here. So for the point charges, the electric field can be written as an E is equal to 1 by 4 pi epsilon naught into Q by R square. So this is for an point charge or an independent charges or isolated charges. But for a discrete charges, this is for the discrete charges. But for a continuously distributed charges are there. What do you mean by continuously distributed charges in the sense? For example, there is a wire like this, okay, long rod or wire or anything is there, which is positively charged one or charge is distributed on its surface like this. For the conductors, the charge will be distributed only on the surface. So let the charge per unit length called as an linear charge density, which is can be represented by the lambda is nothing but a charge by length L. This is the lambda is constant for this particular case. Then electric field at a particular distance on this one, perpendicular to this one, or else if I try to draw this one, it is a wire having a lambda is a linear charge density. Electric field at a particular point P, which is at a distance R from here, can be written as an E is equal to lambda by it can 2 pi epsilon naught R. So this is the one you can write it where small r is the distance from the point P where you are finding the electric fields. So these relationships has to be remembered because if you try to solve them in the examination, it's a time consuming thing, please. So for all the different objects, you have to remember them, sir, please. Now for another object, if it is going to be the second one, if I go on to take the ring. So what is an electric field for a ring along its axis? So this is the center along its axis at a particular point P. This is the distance x. Let the radius of the ring is going to be the r. Radius also a linear object. Let it be the lambda conditions. Okay. Then what will be the electric field for this particular ring at a particular point on this one? So if I try to solve them, we need to consider an elemental point over here. The electric field will be directed in this case. It can be resolved into the two components. Let this be the dE cos theta. If this is your theta with respect to the x-axis. Okay. So on that sense, if you can write it. So if you derive, your vertical components will be cancelled. That will be the Ey. And only horizontal components E cos theta will be left over. And when you solve them, then you will be getting the electric field E is equal to 1 by 4 pi epsilon naught into charge is going to be the q into x by this will be the r square plus x square whole to the power of 3 by 2. Okay, so this is the electric field on the axis of a ring. Okay, at the center it will be At the center means x is equal to 0. Since x is equal to 0, your electric field value E will also be 0. And electric field of a ring will be the maximum when your x value is equal to R by root 2. At this particular instant, you can have the maximum value of the electric field of a ring. Now coming to the other object, suppose if I take another object of this one as an that is, so this is going to be the third object I am taking, which is a disk. So for the disk, what is an electric field? So if you consider a disk like this of a radius r and let the electric field at a particular point called as an P, which is at a distance of x from here. So you can take an element over here in this one, that the shape of the element will be a ring, and because of an element of the ring, that is total electric field of a disk, can be calculated between the 0 to r, that is an electric field of a ring. You can do this one. So the value or the formula for this one, you will be getting it as an E of the disk is equal to, that is a 1 by, or else charge by q by 4 pi epsilon naught into r square of 1 minus x by root over r square plus x square. Or this can also be written as an sigma by 2 epsilon naught of 1 minus x by root over r square plus x square. Or from the diagram, if I take this as an angle, sorry, this as an angle theta over here, then this also can be written as an sigma by 2 epsilon naught of 1 minus cos theta here. Sigma is nothing, since it says what is sigma? Sigma is nothing but a surface charge density. Surface charge density, that is sigma is equal to total charge by surface area. So like this for the disk. So you can also find for the different objects, that is for the sphere, if it is sphere, is going to be the E is equal to 1 by 4 pi epsilon naught total charge on the sphere by distance of r square. Okay, if it is a hollow sphere, for example, if it is a hollow sphere or a conducting sphere, inside the conducting sphere, the electric field will be equal to the 0. Okay, inside a conducting sphere or hollow sphere, electric field E value will be equal to 0. This is the outside or on the surface. On the surface means you are going to write it as a small r is equal to capital R for on the surface. Okay. Now for the non-conducting sphere condition, if I go for this one, non-conducting non-conducting sphere, the outside and on the sphere it will be the same. But when you go for the inside, electric field formula can be written as n rho by 3 epsilon naught, since for the non-conductor, charge will also resides inside. The rho is called as an volume charge density. It is called as an volume charge density. Got it? So volume charge density in this case, please, rho. So that is rho is equal to total charge by volume here. So these are the very, very, very important relations for a sheet or for a normal sheet like this. The electric field will be acting in this direction. It's a completely charged plate or charged sheet. E can be written as a sigma by 2 epsilon naught. This is another important relationship. So it should be these all the formulas of the electric field has to be. They should be on your fingertips, because these are hard to derive at the time of the examinations. So you should remember them to apply to the corresponding application that is being given in your question. So a hollow metal sphere of radius r is uniformly charged here. So electric field due to the sphere at a distance r from the center. So if I just go for the derivation for this one, I'll take the opportunity to derive this equation for solving this one. So generally electric field formula will be the 1 by 4 pi epsilon naught into it is q by r square, it is outside. So from the center, if the point P lies at a distance r, where in the first case small r is greater than the radius, where r is nothing but your radius of the sphere. So in this case, electric field is inversely proportional to the r square. So the next one on the sphere, so this is outside. If it is on the sphere, then also E is equal to 1 by 4 pi epsilon naught into Q by capital R square, since on the sphere small r will be equal to your capital R. Okay, now if I go into this particular thing for a uniformly charged halo metal, is actually given halo thing. So on that sense, the shape of the graph will be how? So it will is going to be the shape of the graph. If the electric field is on the y-axis and distance r is on the x-axis. So inside it will be 0. Inside the halo sphere, it should be the 0. So that means from 0 to small r is equal to capital R, you cannot find any electric field. After that, it gradually comes down decreasing. It's an inversely proportional condition. Please. In here, E is inversely proportional to the R square. And you'll find the maximum value at E maximum is equal to, at this particular point, you'll be getting. That is, if I try to write this one in the sigma terms, that is 1 by 4 pi epsilon naught. Charge I'm converting into the sigma into surface area of the sphere, that is 4 pi capital R square by R square. Then it will be the sigma by epsilon naught. So that is your maximum value. So maximum will be on the surface. Gradually it will be reducing and comes down to 0. So inside it will be 0. 0 as R increases from, for small r is equal, this is the case, 0 to this one, up to the small r is equal to capital R, it is equal to 0 electric field here. And after that, it reaches to the peak value, and from there, as R value increases, your field will also decreases. Got it? So like this, the functions will be there, please. So next one. So here, as we have discussed the field because of the different objects, I'll again go for the formulas. E is equal to. So it's for an straight wire, it will be the lambda by 2 pi epsilon naught r. This is for an wire or a rod which is uniformly charged. Okay, this is next for an ring, it will be what is 1 by 4 pi epsilon naught into q into x by, this will be the x square plus r square whole to the power of 3 by 2. This is for a ring, and electric field for a disk can be written as an sigma by 2 epsilon naught of 1 minus x by root over, this will be the r square plus x square. And for the sphere, electric field will be 1 by 4 pi epsilon naught into q by r square. So this is on the sphere or outside the sphere. For a non-conducting inside a sphere, it is E is equal to sigma by that is nothing, sorry, rho by 3 epsilon naught. So these are the different conditions, Nana. So these formulas needs to be remembered, please, here. Okay. So next one in this case is going to be the two parallel infinite line charge densities are being given. So this is your line charge density first wire, having a charge density of lambda plus lambda. There is another one which is having a charge density of lambda, separated by a distance of 2r here. Free space. What is an electric field midway between them? At this particular point, he is asking. So since it's a positive charge, the field direction should be in this one. Since it's a negative charge, field direction should be in this one. So both of them are in the same direction. Then E should be equal to the E1 plus E2. So E electric field because of a plate in which can be written as n. So sigma by 2 epsilon naught plus sigma 2 by 2 epsilon naught. Sorry, this can be the values have been given as n lambda na. So instead of the sigma, we can write it as n lambda. So what is the formula for the lambda, sir? By the way, for a line charges, electric fields that is even can be written as an lambda by 2 pi epsilon naught into small r. So distance is going to be the 2r means this should be the r. Another one is lambda by 2 pi. Lambda by 2 pi epsilon naught into distance is going to the r because midpoint over here. From here midpoint is at a distance of r. From here also midpoint is at a distance of r. Then on adding these two things, this is your E2. Both the fields are in the same direction, so net field E is equal to E1 plus E2. This is the situation. Okay, so you need to add up both of them, so you can get you the answer, please. So that means it should be the lambda by pi epsilon naught r. Lambda by pi epsilon naught r. Like this, you can solve this one. Next one. So you can use or you can solve the questions by using the promo code of this one. You will find a lot of number of the questions on the Rise platform for the get you can get the subscription by getting a discount of 10% by using this promo code. So please go through this. All the questions, different models are being provided in the web, your page or whatever it may be in the site, please. Now, a spherical resistor, spherical conductor of a radius is there, which is 10 centimeters, has a charge on that one is being given. So it has been already charged, uniformly distributed over there. The magnitude of the electric field is asking at a point 15 centimeters from the sphere, please. From the center of the sphere, let this be your sphere. From the center of the sphere at a distance of 15 centimeters. 15 centimeters. He is asking the what is the magnitude of electric field is how much. So how do you solve the electric field? Since it's a sphere and the point is also outside, this can be written as an 1 by 4 pi epsilon naught charge q by r square. So this value is going to be the 9 into 10 to the power of 9 into charge 3.2 into 10 to the power of minus 7 by distance is 15 centimeters, 15 square into 10 to the power of minus 2 whole square. Sorry. 15 square into 10 to the power of minus 2 whole square. Okay, now? So now when you solve this one, how much you should be getting, sir? So this is going to be the 9 into 18. This one is 8, 1, 27 plus 1, 28, 288. Uh, that is 28.8 into 10 to the power of into 10 to the power of minus 7. So correspondingly, and this is 10 into 10 to the power of 9 by 15, 225 into 10 to the power of minus 4. Now solve. So if you solve this one, you can get your corresponding answer is going to be how much. So it's a tricky calculation. So you might have understood how we need to substitute the values, please. Now coming to this one, charge is distributed within a sphere of radius r with a volume charge density rho r is equal to a by r square e to the power of minus 2r by a, where small a and capital A is telling to be them constants if q is the total charge of the if q is the total charge of the charge distribution, radius r is how much is asked. Okay, so we have got the charge distribution, that is charge density here. Sorry, and it's a total charge q is the total charge distribution is giving. Now r is the radius. Fine. He is asking what's a volume charge density, charge distributed H, or if q is then radius r is asking. So how to find out this radius r is going to be how much? Any ideas, sir? The total charge or the dq can be written as an rho r into dv. dv is nothing but an change in volume. So change in the volume, can I write it as an this is dq is equal to a by r square into e to the power of minus 2r by a. Okay, this is your the charges and volume can be written as an surface area into thickness. Or surface area is how much? 4 pi small r square into thickness is dx. Fine. So this is the one charge. Now you can go for the integration q. Remove the common terms. A is the one. Uh, A is the one. Another one is 4 pi. If I bring it to inside, A into how do you multiply? A into sorry, A by r square into r square into. So this is the entire thing. We need to multiply e to the power of minus 2r by a. This can be removed. This is equal to the a into 4 pi of capital A into. Okay, sorry, I have written this one, I suppose. Yeah. So here we have taken already the a values here. Look at here, a by r square, a for in the 4 pi r square, 4 pi also have taken. R square has get cancelled. Then remaining is going to be the 4 pi a into e to the power of minus 2r by a. Okay. So now this is the one we need to go for an integration to get the dq here integral of this entire thing, please. Where the radius value changing from 0 to capital R. When you integrate this particular thing, you should be getting the total charge is going to be how much? A point charge q produces a magnetic field. He has magnitude, that is E value he has given, that is 2 in Newton per Coulomb at a point distance r is equal to 0.25 meters. What is the charge value he is asking? So this is your electric field, distance of separation. What is the formula for the electric field? E is equal to 1 by 4 pi epsilon naught charge q into r square. What is your E value is? Electric field is 2 is equal to 1 by 4 pi epsilon naught 9 into 10 to the power of 9 into charge you should be getting. Distance is going to be 0.25 whole square. So from this one, q is equal to, you need to find, that means q is equal to 2 into 0.025 or 0.25 whole square by um, 2 into this one by 9 into 10 to the power of 9. This is the one we need to solve it to find out the value of the charge, whatever he is asking. Got it? So now, next one, please. Two spheres, two spheres A and B of radiuses he has given here. Fine, in this question. Given a charge of 80 microcoulombs, 40 microcoulombs separately, if they are connected by a fine wire amount of the charge. If two spheres are there and when you start connecting them with a wire, charge starts flowing from the one to the other until they attain the common potential V. Common potential. So let the initial charge on this one is going to be 80 microcoulombs and this one is going to be the 40 microcoulombs. What will be the capacity? C1 is equal to 4 pi epsilon naught r, where r is the radius, that means 4 pi epsilon naught into 2 into 10 to the power of minus 2. Since it's in centimeters, so 2, this will be the 8 pi epsilon naught into epsilon naught. Next to C2, sir. C2 also same formula, 4 pi epsilon naught r. Substitute the r value is equal to how much here? 6 centimeters, please. Okay, here it has given the radius only, sir. He has not given the diameter. So this should be the 4. 4 into 4, this will be the 16 pi epsilon naught here. 4 pi epsilon naught r that is capacity, can be written as an 4 pi epsilon naught into what will be the radius of the second one is 6 centimeters, 6 into 10 to the power of minus 2, which will be 24 pi epsilon naught into r square. These are your values of the C1 and C2. From the C1 and C2 and having the initial charges 80 microcoulombs and 40 microcoulombs, you can find out the initial potential is equal to how much? That is Q1 by C1 and as well as V2 is equal to Q2 by C2. Okay, so initial potential you can find it out when the charge starts. For common potential point will be V is equal to V1 C1 plus V2 C2 by V1 plus V2. This is your relationship, please. Substitute the potential of the first one by calculating the V1 is equal to Q1 by C1 and C2 this one. Charge on this particular thing, please. Sorry, capacity on this one, C1, V1 C2 plus V2 C1. So substitute these values, you can get the common potential also here. Now charge for the charge flowing, you have to find Q1 dash is equal to C into V and Q2 dash is equal to C into V2. After finding the final charge on the first one and second one, you can find how much charge has been flown, that is delta Q is equal to Q1 dash minus Q1. Like this, you have to find the net charge or the whatever the charge that has been displaced. Now, next question. The charges on the two spheres, these are the unlike charges plus and minus. They experience a force F if each of them is given an additional charge of minus Q. The new force of attraction is going to be how much? So two charge spheres are there. This is the first one having a charge of plus 7 microcoulombs. It is another one which is having a minus 7 microcoulombs. To this one, he is adding minus 2 micros and this also minus 2 micros. Then this will be converted as an 5 microcalar capacities since it's a sphere. And here, when I add this one, it's going to be going up to the minus 7 micro coulombs, right, sir? So this will be your maximum value. Now you need to find out the force of attraction between them 5 and 7. Find the force of attraction. How do you find the force of attraction? You have got the charge values are here. Okay, so charges are there. The experience initial force is going to be the x. We know that F is proportional to the product of the charges. Initially, how the charges are there? Two charges which are what are the initial charges? Is 7 and 5. What is the final charges of yours? 5 and 7, same thing. Okay, so it should be the that one. So same case, next one. So this ends your conceptual discussion for today's, please, on the electric fields and the charges. So please be careful. You will be getting definitely a one sum on this particular thing. And you will have the more number of the sums on that platform. You can use this particular code to have the very, very important thing, please. Important questions are being placed over there. So next class of yours is going to be the